Hi everyone, my name is Alima Balo, and today we talk about the motion of a falling object. We talk about the concept, data collection and analysis, computational versus observed models, results, and conclusions. The purpose of the lab was to extract motion data of a falling object and construct two models using Newton's second law. One model accounting for the gravity force, and one model accounting for the gravity force and the drag force. After analysis, the outcome results were similar, but showing some differences that will be discussed later in the presentation. Data collection and analysis. Here is the video of the falling object in tracker. We extracted the initial condition as well as the final condition. The initial velocity was 0 because the ball was dropped. Computational model versus observed model. Here is the model without the drag force, so only accounting for the mass. As we can see, we inserted the initial condition into Python, and the net force was only equal to the gravity force. For the model 2, we incorporated the drag force, which is in the opposite direction of the gravity. We found the proportionality coefficient of the air resistance through trials and errors to match the final position of the observed motion. And in this case, the net force was equal to the weight plus the drag force. We can see here the motion accounting for both forces. The weight is constant because it's equal to the mass, and the gravity constant who doesn't change in time. And the drag force, which is proportional to the velocity of the ball, is 0 and then increases with time. This is why the drag force appears after the motion. Results. We have the graph of the two computational model and the observed one. As we can see at the beginning of the motion, we set the initial condition the same for all three of them, so they fit perfectly. At the end, the prediction with the drag and the gravity matches the final position of the observed one. In between, we can see that there's some discrepancy, which can be explained maybe by the camera that was recording at an angle, or the ball was falling too fast and it was difficult to track the center of mass, or the ball did not fall straight, so there might have been another force smaller than it can be acting on the ball horizontally. However, overall, the model with the drag and the gravity predicted better than the one without the drag. We can summarize this experiment by saying that Newton's second law is valid for an object moving with a non-constant velocity, and that the model with the drag force was better than the one with gravity only. Discussion. What does it mean? Which model predicts a terminal velocity? So the terminal velocity is when a falling object reaches its maximum velocity. In this experiment, we can see that for the graphs with the drag and without the drag, the one with the drag is starting to curve, which indicates that it's reaching the maximum and then is going through that maximum. So we can say that the model with the drag is predicting a terminal velocity. However, both of the graphs didn't reach their maximum velocity in this experiment. For the one without drag, it's a straight line because the ball is expecting to continue to accelerate since there's no opposite force acting on it. What if the object was initially thrown downward? Would the terminal velocity in this case be the same? Yes, If the object was thrown downward, which means that initial velocity will be non-zero, the terminal velocity will be the same. As you can see on the graph, both lines tends to go to the same max. Thank you. This is the end of the presentation.